All right, hi everyone. We're looking at our next topic with our square roots. Last time we looked at breaking down perfect squares. Today we're going to visit how to break down those numbers that aren't perfect squares, meaning there is not a number multiplied by itself that'll give you that value inside that radical sign. So let's review just a little bit on the ways that we broke down your perfect squares. Remember, first off, we looked for pairs. So in this case, if I break down the 4, I can break it down to a 2 times 2. There is my pair. So the 2 can come outside of the radical, and that is my final answer. Let's try another one real quick. 81. Again, we talked about how you can break it down by doing simple division, but if you recognize the pairs right away, that just makes it a lot faster. So I have 9 and a 9 for a pair, meaning I can bring just a 9 out, just one of the actual number. All right, square root of 49, 7 times 7. So there's my pair. And so I just need to bring one of the 7s out. And then the last one, 25, 5 times 5. I only need to bring out a single 5 for my final. Now let's take a look at your non-perfect squares. And we do have some patterns to follow, very similar to the last one. So first off, break down the number to get to prime numbers. Okay, so we're still going to do that. Second thing, look for pairs like we did before. That we can bring out. All right, so let's start with that. Let's try that first, and then we'll come back and add to this what we need to. All right, so our next example here. All right, we have an 8. So I want to break this down into primes. And again, I don't want to use 1 times 8 because I'm still going to have to break down the 8. We want something other than 1. So I can do 2 times 4. Make this a little bigger. So I'm done with the 8. Now, my 2 cannot go any farther, but the 4 can. So my 4 can go farther. I'm done with the 4 into a 2 times 2. This is where we look for pairs. And again, they don't have to be at the same level. They don't have to come off the same branch. I just need pairs. So any pair that I find, again, like before, comes on the outside. This time, though, notice we have a leftover. So something special is going to happen to those leftovers. So let's add that to our next step. Third thing, anything left over will stay inside the radical. And remember, like last time, that was our radical sign. So anything that doesn't have a pair stays inside that. And then like last time, we multiply anything, we multiply back together. And it doesn't matter if it's on the inside or the outside. So from the outside, if I have more than one thing more than one pair, I multiply it back together. And now on the inside, if I have more than one left over in the inside, it gets multiplied back together. And we'll see some of both here in just a second. All right, so because this 2 is left over, it stays inside. I'm sorry, I can't spell. So we have our radical and the 2 left over. So final answer, 2 square root 2 That's my final. Let's try another one. 24. Again, I'm going to break it down. I know I can do 4 times 6. Okay, the 4 I can break down farther into a 2 times 2. There's a pair, bring it out. The 6 can go farther. 2 times 3. There are no other pairs left once we're done with that 6, so they stay inside. So square root 2 times 3. And again, this is what it means by multiply anything that's left over back together. So my 2 in the front stays by itself. But the 2 times 3 on the inside will go back to its 6. So 2 square root 6, final answer. Let's try another one that maybe has a few more branches this time. So I have 48. I know I can do 6 times 8. Both of these can be broken down. 6 can become 2 times 3. 8 can become 2 times 4. And right now I have a pair, even though they're not at the same place. So I have a pair of 2s. So I bring the 2 out. Now the 4 can go farther, but unfortunately that 3 cannot. So the 3 stays. My 4 can become 2 times 2. There's another pair that can come out. So there's another 2 outside of the radical. My 3 is left over inside. So again, I can multiply the 2 times 2 and I get the 4. So 4, nothing left over inside except the 3. That's my final. Now notice I'm not taking any of these to a decimal. This is called simplifying the radical. We only simplify it. We're not taking it to the exact decimal value. Let's try 72. I can do 9 times 8. All right, both of these can go farther to get the 9. I can do 3 times 3. There's a pair. So it comes out front. I can break down the 8. 2 times 4. My 2 is done, but 4 can go farther to 2 times 2. And again, there's another pair that can come out front. My 2 is left over inside the radical. So again, my 3 times 2 becomes a 6. So 6 square root 2, my final. All right, let's try one. Let's keep going. Try another one. 27. I can do 9 times 3. And again, my 9 can go farther to 3 times 3. There's my pair. I have a 3 left over for the inside. There's nothing here that I need to multiply back together this time, so 3 square root 3 is the final. Let's get something a little bit bigger this time. So now we have 162. All right, I know that, again, if you don't know a number right away that goes into it, it is an even number, so 2 will divide into it, and I get 81 in return. And 81 I can break down because that's a 9 and a 9. Now, even though 9 can go farther, we only need to see if we have a pair. If I automatically have a pair of 9s at that level, I don't have to take it any farther. So right now, my 9 will come on the outside. The 2 will stay on the inside. There's nothing I need to multiply back together. So 9 square root 2 is my final. Let's try another one that's a little bit bigger. 450. All right, it ends in a 0, so I know it's divisible by 10. So I can do 10 and 45. All right, both of these can go farther. To get 10, I can do 2 times 5. And neither of those can go farther down, so let's check out 45. For 45, I can do 5 times 9. And right now I have a pair of 5s. So I can bring a 5 out. My 9 can keep going to a 3 times 3. There's a pair. I can bring the 3 out. The only thing I have left over is the 2, which again stays inside. Multiply these back together, your 5 and 3 for a 15. So final answer, 15 square root 2. All right, let's try one more. I think we have one more, maybe 2 more. Maybe 2 more after this one. But again, we're trying some bigger numbers. All right, so again, I know 216 is an even number, so I can for sure divide it by 2. And I get 108. Okay, that's as far as the 2 is going to go. But my 108 can also be divided by 2. Or if you can think of a different pair of numbers that you can multiply to get 108, by all means, you can use those. All right, right now I have a pair of 2s. So I can bring a 2 out. Done with the 108. 54 can go farther to a 9 and a 6. And both of these can go farther. 9 can become 3 times 3. There's a pair. Bring that 3 out. 6 is a 2 times 3. Neither of these have anything they can match with, so they stay inside. So square root of 2 times 3. Now we just need to clean this up, and now we have more than one piece on the outside and inside. But again, they just get multiplied together. All right, so outside is a 6. Inside my square root is a 6. So there is my final. Now, keep in mind, guys, whatever is left over inside your square roots, that is technically a decimal value. So you don't want to go back and take what number outside times whatever the number is inside and get a new value. Because again, that square root of something is just the idea of a decimal number. So for example, this one, talking about for this one. 75, I can do 3 and 25. My 25 can go farther to 5 times 5, and there's my pair. So I can bring a 5 out. Here's 3, whoops, meant to box that, is left over for the inside, so it stays inside. And so my final answer, 5 square root 3. Now again, this is not the same as 5 times 3, because 5 multiplied by 3 gives you 15. But again, this is the square root of 3. And to show you what I'm talking about, let me pull up my calculator real quick to show you you actually get 2 different values. If all I do is 5 times 3, there's my 15 over on the right, way over here. But 5 times the square root of 3 is a decimal value, all right? So they are not the same thing. That 3 inside the radical is a decimal value. It is technically about 1.7. So again, we don't want to think about it the same as if it was 5 times 3, because it's not 3 whole pieces, 3 whole units. It's the square root of that number, okay? So just be careful with those. All right, let's check out our last one, 63. All right, I know I can do 9 times 7 to get 63. My 9 can go farther into a 3 times 3. There's my pair. So I can bring that 3 out. 7 is left over on the inside. So it stays inside that radical. And so my final answer, 3 square root 7. Now, just one final words to you guys. It does not matter which one you put first when you're doing your initial two factors. I could easily do 7 times 9 Either way, you get the same answer. It does not matter which one you put first. All right, so just want you guys to be aware of that. Okay, guys, so I hope you enjoyed learning a little bit about how you simplify out non-perfect square roots, and this is what makes them non-perfect, because you're left over with something to go back inside. If we had nothing left over, that makes it a perfect square, because you can break it down with nothing left. But guys, please don't hesitate to reach out to me if you have any questions. Bye, guys.